You're on a beach, staring at the endless ocean. Now imagine that the ocean is just a tiny drop compared to the universe. Crazy, right? But here's the wild part. What we see is just a tiny slice of what's out there. The universe is so vast that it's almost impossible to comprehend. Today, we're zooming out, from Earth to the edge of everything we know. Ready to feel tiny in the best way? Let's dive in. We begin with Earth, our home. It's a tiny blue dot floating in the immense cosmic ocean. This is where everyone you've ever known, every human who's ever lived, and every story ever told has taken place. But as we zoom out, Earth starts to look smaller and smaller. The first stop on our cosmic journey is the Moon, about 384,000 kilometers away. That's so far that if you drove a car at 100 kilometers per hour, it would take you over 160 days to get there. From the Moon, Earth looks like a fragile blue sphere, a humbling reminder of how small we are in the grand scheme of things. Next, we head to the Sun, about 150 kilometers away. The distance is called an astronomical unit, or AU, and it's the standard measuring stick for distances in our solar system. Light from the Sun takes about 8 minutes and 20 seconds to reach Earth. If you were to travel that distance in a commercial jet, it would take you 19 years. The Sun is a fiery giant, providing life-sustaining energy to our planet from this incredible distance. It's a stark reminder of how vast space is, even within our own solar system. Now let's set our sights on Mars, our red neighbor. At its closest, Mars is about 54.6 million kilometers away. When it's on the opposite side of the Sun, that distance stretches to 401 million kilometers. Traveling to Mars at the speed of a commercial jet would take over 50 years. The vast distance has been a huge challenge for space exploration. The rovers and probes we've sent to Mars embark on a journey that's not just long, but also complex due to the constantly changing distances and orbital dynamics. As we move further out, we reach Neptune, the distant ice giant. It's about 4.5 billion kilometers from Earth. Sunlight takes about 4 hours and 15 minutes to reach Neptune. This staggering distance shows just how enormous our solar system is. Launched in 1977, Voyager 1 has been traveling for over 4 decades, and it's covered more than 22 billion kilometers. It's the farthest human-made object from Earth, a silent wanderer in the cosmic sea. In 1990, at the suggestion of astronomer Carl Sagan, Voyager 1 turned its camera back toward Earth and captured the iconic pale blue dot image. From 6 billion kilometers away, Earth appeared as a tiny faint dot in the vastness of space. Sagan's reflection on this image reminds us of our responsibility to cherish and preserve our only home. At the very edge of our solar system lies the Oort cloud, a theoretical sphere of icy objects. It's thought to extend up to 100,000 astronomical units from the Sun, or about 1.9 light years. This is where the Sun's influence ends, and interstellar space begins. The Oort cloud is the final frontier of our solar system, a boundary zone where the cosmic journey into the galaxy truly begins. Now let's leave our solar system and head to Alpha Centauri, the closest star system to the Sun. It's about 4.37 light years away, or roughly 41.3 trillion kilometers. At such distances, the astronomical unit becomes impractical, so astronomers use the light year, the distance light travels in 1 year. Even with our current technology, a journey to Alpha Centauri is almost unimaginable. Voyager 1, traveling at 17 kilometers per second, would take over 70,000 years to get there. This immense distance highlights the vastness of space and the challenges of interstellar travel. Our journey now takes us to the grand scale of our home galaxy, the Milky Way. It's a vast spiral galaxy about 100,000 light-years in diameter and home to hundreds of billions of stars, each potentially hosting its own planetary systems. Within this immense structure, there's a tiny sphere known as the human radio bubble, extending about 100 light-years from Earth. This bubble represents the farthest extent of human influence in the cosmos, the reach of our radio and television broadcasts into space. Beyond this bubble, it's as if humanity never existed. The scale of the Milky Way is so vast that our entire recorded history is but a whisper in the cosmic wind, undetectable beyond this small bubble. As we leave the Milky Way, we enter the realm of intergalactic space, where galaxies float in the cosmic ocean, separated by mind-boggling distances. Our galaxy is part of a small cosmic neighborhood known as the Local Group, a cluster of more than 50 galaxies spread across about 10 million light-years. The Local Group includes not just spiral galaxies like the Milky Way and Andromeda, but also a multitude of smaller dwarf galaxies. The distances here are so vast that light from one end of the local group to the other would take 10 million years to traverse. This scale dwarfs anything within our own galaxy, underscoring the enormity of the universe. Intergalactic space is a silent expanse, a vast wilderness between the islands of galactic light. In this immense void, our galaxy, home to our entire history, is just a tiny speck among many, a single story in the grand cosmic library. Now, let's zoom out even further. Beyond the local group, we encounter the Virgo supercluster, an immense collection of galaxy groups and clusters, including our own local group. It spans about 110 million light-years in diameter and contains thousands of galaxies from at least 100 galaxy groups and clusters. Each of these galaxies has its own myriad of stars and planets. The Virgo supercluster is a titanic structure in the universe, but it's just a small part of an even larger structure. That structure is the Laniakea supercluster, which includes the Virgo supercluster and extends over 500 million light-years. Laniakea, meaning immense heaven in Hawaiian, truly lives up to its name. It contains the mass of 10 million billion suns and is a gravitational masterpiece, with galaxy clusters, superclusters, and countless celestial bodies bound in a cosmic web of attraction and motion. At the heart of Laniakea lies the Great Attractor, a mysterious region of space that exerts a massive gravitational pull on the galaxy within this supercluster. In this vast expanse, our Milky Way, the entire local group, and even the Virgo supercluster are just tiny components of this gigantic structure. Laniakea provides a profound context for our existence. We are part of something far greater and more majestic than we can fully comprehend. Finally, we reach the boundaries of the observable universe, which stretches about 93 billion light-years in diameter. This raises a fascinating question. If the universe is only 13.8 billion years old, how can it be so vast? The answer lies in the nature of cosmic expansion. The universe has been expanding since the Big Bang, stretching space and increasing distances between celestial bodies. But what lies beyond the observable universe? This remains one of the greatest mysteries of cosmology. Some regions of space are expanding away from us faster than the speed of light, placing them forever out of our view. Consequently, the true size of the entire universe remains unknown and potentially infinite. The observable universe, vast as it is, might just be a tiny fragment of the entire cosmic expanse. We are left with a humbling realization that there might always be regions of space, entire galaxies, and wonders that we will never witness as they retreat endlessly into the depths of the ever-expanding universe. So, how big is the universe? The answer is, we don't fully know. What we do know is that it's unimaginably vast, filled with wonders beyond our comprehension. From our tiny blue dot to the farthest reaches of the observable universe, the cosmos is a place of infinite mystery and beauty. As we continue to explore and learn, we're reminded of just how small and how significant we are in the grand cosmic story.